Welcome back. This is a Laplace functional and operational transforms. The point of this is just to get comfortable with Laplace. They can get pretty difficult, but mostly you're just going to pull stuff out of tables, but it's good to do a little bit of this stuff just to get comfortable. So let's find Laplace of the derivative with respect to time, so d dt of sine omega t. So two methods, right? So there's method one. We're gonna do this. We say let f of t equals sine omega t. Just this thing in here, right? So if that's the case, then the Laplace of f of t is Laplace of sine omega t. Pardon my sines and cosines are not very pretty. And this we're just going to pull out of the table here. So maybe I should even write those down. So there's a whole bunch of rules we're going to be using. So let's see. Let's put them right here. So there's f of t, and we're transferring over to f of s. So from time domain to frequency domain. So the first rule we've used here is from table 12.1.5, and it's sine omega t is omega over s squared plus omega squared. So this is the approach here, is just pull these out of the table. Don't derive these using the Laplace definition integral. That's way too difficult. I mean, you could if you wanted, but I'm not asking you to do that. I just want you to get familiar with these things, and this is a good example to get familiar with these. Anyway, so Laplace of sine omega t, just pull it out of this thing here. It's omega over sine squared plus omega squared. So that's rule 12.1.5. So let's call that big F of s. Okay. So if that's the case, then Laplace of the derivative d dt of f of t is, and then we have another rule. We have this from table 12.2.3. We have this rule f prime of t is s big F of s minus little f, time domain f, evaluated at 0 minus. So apply that rule here. So up here we use, let's see, we use 12.1.5. You could even write that on the equal sign here. And here we're using 12.2.3. So applying this rule, the derivative of f of t, it's inside the Laplace here, right? We're applying this rule inside the curly brackets. So it's s f of s minus little f 0 minus. And then to get so it's the whole thing. It's not just inside here. This rule is saying that given f prime of t, the Laplace of that will be this thing. So here's f prime of t just with a different notation here. So the whole thing is going to frequency domain. So that's part of these the reason we're even working chapter 12, quite honestly, is in and of itself, chapter 12 isn't, I mean, it's useful, but there are better ways to do it. But we need to kind of play with this stuff so that when we're using it in later chapters, it makes more sense. Anyway, moving right along, we can plug these things in and get the final answer. So this is S, and we know f of S. We just big F of S. We just solve for that up here. So this is omega over S squared plus omega squared, and we know little f is sine of omega t, and we're evaluating that at 0. So sine of 0 is 0, and so then your answer is just S omega over S squared plus omega squared. That's the answer. So this is also, this answer is, oh no, it isn't in the book. Okay, that was method 1. We could also do method 2. That is, we could differentiate first. Like here we sort of did the Laplace first, and then we did the differentiation, and then we, then we plugged in some stuff. I mean, we could differentiate first and then transform. So if we do that, then d by dt of sine omega t is just omega cosine omega t. So the Laplace of omega Laplace of this stuff would be the Laplace of that stuff. So Laplace of omega cosine omega t is just, you can factor out the omega and take the Laplace of cosine omega t. And this thing here, we have a rule for that. This is table 12.1.6. We have cosine omega t is S over S squared plus omega squared. So this is the W, and then applying Laplace of cosine omega t, this rule down here, we get S over S squared plus omega squared, which is just S omega over S squared plus omega squared. It's the same answer as up in here. Okay, that's here. I guess here we this was actually rule. If you want to get picky, we pulled the constant out. That was actually another rule. Like, so here we applied rule 12.1.6, and here we applied rule 12.2.1, which is just saying that you could factor out a constant.